Hello, everyone. Can you all hear me on your headsets? Yeah? Cool, awesome. Welcome. I'm ABK from here for Jay, and these headsets are amazing. It feels like I'm talking in a huge room, yet it's all super quiet, right? For people without the headsets, it's awesome. Okay, so thank you for coming to this talk today. This is going to be full stack knowledge. I'm going to talk through some Gen AI context stuff, a little bit about RAG, retrieval augmented generation, and then also this idea of a knowledge stack and how to represent that in a data model. So it'll be a lot of fun, I think. I'm going to have some demos. If the Wi-Fi all cooperates with me, that'll be great. We've all seen these memes about Gen AI, whether Gen AI is a sock puppet, and it's a sock puppet because it reflects the person who's asking questions, right? So like you're actually controlling Gen AI when you're at ChatGPT and you're typing in stuff. The things you talk up to ChatGPT about, it reflects back to you. That's why it seems so friendly. It's actually trying to mimic you in some ways, right? The parrot aspect is also, of course, quite appropriate for Gen AI because we know that it's really just mimicking a body of knowledge that it knows about. It's heard all these phrases and it's just playing them back. It thinks at the right time based on like what you're telling it. There's another metaphor that I really love, another meme that I really love, which is thinking about Gen AI as alien technology. And on the left there, these bullet points are all kind of the observations everybody's made about like the challenges with LLMs and Gen AI. And the alien technology is my favorite analogy because it helps us as developers start to think about, well, cool, this is really neat stuff. Fine, it's a parrot, fine, it's a sock puppet, but we want to build apps. So how do we think about building apps? And the alien technology meme lets us think about Gen AI and LLMs as this alien technology that has landed on the ground. And we've all seen the sci-fi films where somehow humanity gets into possession of a crashed ship or whatever it might be, and like there's a power source or there's something that somehow we manage to figure out how to tie into, and like we can build stuff with and then take advantage of this alien technology. Think about Gen AI that same way and put it in kind of this box. And like, okay, how do we talk to this box? Now as developers, we're like, okay, let's see what the box does. Let's figure out what we can do with it and then how we can extend it for things we're trying to do. So that's the whole idea here. Within thinking about it as a black box, as this alien technology, it's these last two bullet points that are the most important. It's, okay, great, we know that it's been trained on general knowledge of the internet, but it doesn't know anything about the databases we already have. So how does that work? How do we actually get our data so that the LLM can take advantage of that? And it's got some explainability problems. Like, okay, you might even provide it with some data, but then how does a user who's using your application know the outcomes are actually the right outcomes? How do you know that you're giving your users facts about the information that you have in your database rather than stuff that the LLM has made up? So you want both aspects. You want special knowledge, and you also want to be able to explain answers the LLM is giving based on that knowledge. So that the LLM might still come up with something that's in Shakespearean rhyme, but you want to be able to say, actually, that Shakespearean rhyme comes from this set of data, so that the user knows that it's actual facts. If you are in some kind of business, like let's say, you have business policies on refunds and things, and you've got a customer support bot. You don't want the customer support bot to be making up new policies, right? You want those to be grounded in the actual facts of the business. Okay, so how do we integrate with the alien technology? There's two things I want to talk about in that regard. There's the practical aspect of like how do you actually put stuff together, and then once you start to put stuff together, just like with LLMs themselves, there was a scaling realization that like at a certain level of scale, there was this emergent behavior where you went from complete garbage in the machine learning world to actually useful outputs from generative AI, and that's when all the magic really happened at some level of scale. There's an emerging pattern as well on the data integration side, where we're starting to learn like what data needs to look like to work well with the Gen AI application. So I'm going to touch some based on that a little bit. And then that actually the emergence starts from just the practical developer reality of like just building stuff. So first you just try to get stuff done, then you look at what you've done, try to figure out, okay, what have I done? How can I abstract that, make that reusable? It's the stuff we always apply to any problem that we as developers actually try to tackle. And that is based on this idea of what's called RAG. And a quick show of hands, everyone has heard of RAG? Oh, okay. About maybe half the audience has heard of RAG. So I'll elaborate on that a little bit more. The term RAG you'll hear with Gen AI applications all the time, and it is more formally, it is retrieval augmented generation. So the G is still the LLM part, that is it's going to generate some text or some output based on what you've got, but you're going to augment that generation by first retrieving something from a data source that you trust. So this is how you actually extend it to a database or any other data source you might have, is this sort of design pattern called RAG. This is a normal GenAI application. This is what ChatGPT does out of the box. You've got, somewhere there's a box, I think we actually just saw in the previous talk. You have a chat application, so somewhere a user types something in, hits return, and in a very direct way, you can just take that, hand that to the LLM, more or less. The LLM will look at whatever the user typed in and say, okay, based on that, here's what my response is going to be. And in the kind of meme level of like what is an LLM actually doing there, it is just autocomplete on steroids, right? It's just like, okay, given this text that I've got, here's the most likely text to follow. It might look like it's answering a question, but that's just because you probably asked it something that looked like a question, ended with a question mark, and the natural way to continue that is with an answer. When you hear about prompt engineering, that's the whole idea that you're trying to give enough information in the user typing space. You put a lot of information there, and then hand that to the LLM, helping to try guide it a little bit. So if you ask it a direct question like, okay, what do you know about? The LLM will answer generically, I know about lots of things, right? It's not very specific. So then you try to add more information about what specifically you want it to do, or what information you want to ask about that you want it to retrieve from its body of knowledge. So this is the whole realm of prompt engineering, where all you're doing is really taking that user input and trying to add more and more to that input in the chat area to hand to the LLM to give it enough context so that it gives you a good response, that the autocomplete is the autocomplete you want. So that could even be things like, here's a chunk of code, I'm going to hand you this chunk of code, and then at the end of the chunk of code say, hey, that chunk of code I just gave you, could you explain to me what it does? That's still just prompt engineering. Here's a bunch of text. Part of it happens to be code, part of it happens to be natural language, but that is no development is happening so far. We're just taking a bunch of text, handing it to the LLM, and getting a response. So that's the kind of baseline for all GenAI applications. Get some text, add to the text, that's a big context, and then hand that to the LLM to get an answer. To make that into a RAG implementation, you kind of interject. You take that original user question, whatever it might be, like it's a question about, where is Devworld happening, today? And you take that user question, and rather than handing it directly to the LLM, you say, okay, before I do that, the LLM probably doesn't know about the things that the user's asking right now. Probably because you've given the user some context, like it is the Devworld chatbot. So you're going to ask the Devworld chatbot about Devworld things. Those are things that Devworld knows about that the general AI probably doesn't know about, right? Like ChatGPT doesn't know all the details about the agenda here today, so you can't really ask it about it, right? But if you take the user's question and you turn around and if Devworld had a database, you could say, okay, hey, database, here's a user question. Can you get some information that is related to this question that I can then gather up with the user's question and pass all of that back to the LLM? And then the LLM has all the context about Devworld, let's say, plus the user question, and now the LLM is able to actually generate some kind of a response. So that is the entire idea behind RAG. Take the user question, add a bunch of data you know about in text form to that question, pass it to the LLM. Okay? That was kind of a data flow version of what's happening with the GenAI application. If you step back a little bit, and okay, I'm a database guy, I'm a data guy, so this is where my mind goes to, is okay, what is the data model we're actually dealing with here? What we're trying to do is set up enough context in this body of text we're handing to the LLM. It's not just a bunch of random text, right? There's a user question, there's extra data we want to get from a database. What is the shape of that data? How do we actually find that data that matches the user's question? What does that all look like? So there's a bunch of things that we know in our heads when somebody's talking to us one-on-one. We can see their badges, we know where we are. There's a lot of context we know as humans, person to person, right? The LLM doesn't have any of that. So the goal of RAG is to say, okay, great, let's figure out for this given question, what's the information that's relevant, package all that up and hand it over, right? And the pieces of information that matter are this stack of information. You care about the user who's asking the question. When I ask a question and when you ask a question and you ask a question, the answers may be different depending on what we're asking about, right? We want something that's relevant to us. So the user is part of the knowledge stack. Then, of course, there's an application you're actually using. It's an application that could be for here at Devworld, right? So the Devworld application itself knows about the user. It knows a little bit about the context, like Devworld, so that's great. That context about Devworld is probably kept in a database that is primarily concerned about the agenda, all the people who are here, maybe flight plans for how to get here. I don't know how extensive Devworld knows into our personal lives, but that all lives in a database, of course, and that is specific knowledge to a context. And then there's the general knowledge that an LLM has. So you go from general knowledge here at the bottom all the way to very specific user knowledge at the top. Through all of that, you want to somehow thread the needle for like a given user question for this user in this context with the data I have on hand, knowing I'm going to talk to an LLM. What is the slice of data I need down the stack that I want to package up into what is called a prompt so that I can then hand that to the LLM to respond to a given user's question. So that's why I think about it as a stack. And what's also great about this, of course, is within that stack, both the application as developers and the database as developers, we know we have control over. We're designing the application, we know what the information is that's there, we know the information that's in the database, that stuff we can take advantage of. On the LLM side, you can do some amount of kind of curation or like fine-tuning of the LLM as well. You can actually try to train it to know a little bit more. That's one technique that people take, so you might actually decide maybe for Devworld, we want to have a Devworld LLM that is specifically trained on the agenda. That's hard to do, it's not very reliable to do, and it's actually easier to just say, hey, we know the data set for Devworld, we know exactly what that is. What we really need to do is just provide that at the right time to the LLM, rather than trying to make a custom LLM for Devworld itself. So, we're going to take one dive deeper into just the data aspect of this and what that really looks like. And it turns out that there's like kind of three big buckets that I think about for what the questions are that people ask, what the data source is that might answer those questions, and then what the patterns of access would actually look like. This is where most people start. This is where all chat applications start. You basically have pure text. You've got text that's in, let's say, like the descriptions about like all of the sessions that we've got here today, the description about this conference itself, all that is just plain text. You somehow have that. You want to ask a question that you know is the answer is in the text itself. In larger GenAI applications, there are circumstances where people have, I don't know, hundreds of thousands or millions of like PDFs or customer support documents or knowledge-based information or even like wikis of information that the LLM doesn't have knowledge of, right? That is all just pure text. So the first bucket is really take all that pure text, make that available to the LLM in some way, and then use that for answering questions. The kinds of questions that are great for pure text are really information retrieval questions or information search. Like, okay, tell me about the agenda at Devworld, or tell me about Devworld. What is Devworld all about? A summarization of like all of the things you know about Devworld. That is really text-based. Here's a user question. You're hoping that that question basically maps to some information you've got in the text. You find the most relevant text and you pass that all back. On the other side, kind of the other extreme, like these are almost boundary conditions. There's pure text, and then there's pure data. Pure data is what we as developers normally think about when we've got relational databases, whatever databases you might have on hand, and it's just structured data. So if you listen to data scientists and machine learning, they'll talk about these two things as unstructured data, that's the text, or structured data, that's database stuff, right? So the database stuff is just data that's in a database somewhere. The kinds of questions you would ask, or a user might ask that is appropriate to answer directly from a database are kind of information queries. So it's more like, okay, how many people are here today? Or what's next on the schedule? That is a factual query that you want to actually run that you might be able to deduce from looking at the text, but you know exactly what that is because you've got it in structured data. So you want to find actually the entry for whatever the time of day it is right now. Let's find that time of day. Let's find out what's happening at that time of day. That's a database query as we all already know it. So the challenge is then, how do we take the user query and figure out, okay, that's the database query we want to run. Let's go ahead and run that, package up those results, and again, pass that as text all the way back to the LLM. So what was my example there about Apple, right? Okay, tell me about Apple's main business, or tell me how many iPhones they ran, or they sold in a quarter. Given those two outer boundaries, there's a large in-between area where it isn't clearly just a database query, or it isn't clearly just let me search for some stuff through text. It's a mix of you've got some text that has information, and you also have some data that actually augments that text. It's information about the text, but also structured data that is pure by itself. And so you combine that in this mixed data in the bucket in the middle. So this is structured data with long-form text, generally. the kinds of questions, like the phrase for this is all under the big umbrella of information retrieval, right? Like we know as developers, that's what you're doing with the database. It's an information retrieval access pattern, right? That's what you're doing. In information retrieval, there's search, there's query, and then there's this middle bucket is really about discovery. These kinds of questions that end up in this bucket are you know a little bit about what you're asking, but not everything about what you're asking. It's questions like, okay, tell me who in this audience might be interested in the next talk after this one. That's a factual thing. Okay, what is the next talk after this one? But then, okay, who might be interested in that? Now that's personal information about you that might be in your biography or like things you've talked about. It might actually be factual information as well. I guess that's a potential, right? But it's combining different bits of knowledge that you know about, bringing them together, and then coming up with an answer based on that. So you're actually discovering what might be possible. All of this together is really one thing. You don't want to do just this or just that. With a given user at the keyboard typing in questions, you want to be able to handle whatever they're asking. So whether to direct, hey, search for this thing, hey, this is going to take a query, tell me how many people in the room, or the middle bucket there. You want one system that's going to be able to do all of those things. So this gets back to the emerging pattern of like this knowledge stack, and then how do you actually structure that knowledge stack to make it map to user questions. I call this a knowledge graph. Lots of people have lots of different definitions for what a knowledge graph is. This is my particular definition, to be fair. A knowledge graph for me is really just a way of organizing data into actually layers of information that make sense to people. So that's the key part for me, is that knowledge graphs, like a human being, any one of us can look at data that is shaped as a knowledge graph and understand it. It's got people, it's got events, it's got whatever it is. It's when you had a relational database that is perfectly normalized and actually matches one-to-one with reality. That's the kind of level of model you want here. That, plus, it has some bit of hierarchies as well. So it's not just that you have individual things, but you have the ability to have layered information. So like, let's say we had all the descriptions about the sessions at the conference here today. You might have another layer that is just about conferences in general, right? And like, okay, tell me the description of this conference. There's a summation of all the descriptions about the sessions happening at this conference. So it's a little bit different than just the conference's own description of itself. It is, hey, tell me holistically, give me a summary of like, given all of the topics that are happening here today, what would you call the Devworld, on what are we, March 1st now, right? What's happening in March 1st in Devworld? What are all the topics really about? What are the themes, those kinds of things, right? So it's layered information. And once you've got data arranged in this with layers of specific information that is either text-based, structural, and then how those things are related, this ends up becoming a knowledge graph, and that enables you to actually map really nicely between these three buckets of information you might have and the kinds of questions people ask, whether they are searching questions, query questions, or discovery questions. In practice, this ends up being on the left-hand side. You do vector search for that. Vector search is a lot like full-text search. We're all probably familiar with full-text search. Full-text search is really a character-based, like how close are these characters to this other set of characters kind of a search is usually what ends up happening there. With a vector search, it is more conceptual. So like in a vector search, apple and banana are very closely related concepts, but they're very distant in text, in characters, right? But like apple and apply are very similar in full text search because they're very close in terms of the actual characters involved. So vector search is about concepts and searching based on concepts effectively rather than like a full text search. For the graph queries, or actually for kind of any query you might want to run on the right-hand side, that is the whole effort of like taking some natural language you've got, trying to generate a query that you can run on a database, and then taking that query response and packaging it up. In the middle, you do a mix of those things. You do a little bit of search based on like, concepts, and then you add, okay, here's the concept that I have that is most similar to what the user is asking about, but then you add extra structured information to that as well. Structured information like, what do you know about the user who's asking the question? What else is relevant to that particular text that's there? Maybe the text that came before it or the text that came after it. And I'll take an example actually that'll help make that, I think, a little bit more clear. The example I'm going to work through is from the US, so I apologize. So you may not be familiar with this. This is the SEC is the Security and Exchange Commission in the United States. It manages like all public companies that are publicly traded. There's lots of things that they have to actually comply with in terms of what they report about what their business is, what the risks to their business is, those kinds of things. Also, large investors have to report to the SEC as well, so that everybody has some view on like basically what's happening in the market in the US, okay? So we've taken two forms from the SEC. There's this database called Edgar that has publicly available kind of all of the versions of all the forms. The raw data from this, I have to tell you, is absolutely abysmal. It is custom XML and also weirdly concatenated chunks of XML. It is a nightmare to do the data processing on. But we've done all that data processing, extracted out the relevant bits of text. So like from what we're using here is the Form 10Ks. Those are for public companies that have filed their information about like their, what they're doing these days, what matters to them, what the risks to their business are. We've taken all of that text and extracted that. And then we've also taken another set of forms called the Form 13s. These are from institutional investment management firms. So large financial firms that basically do huge billion-dollar investments into companies. They also have to say, okay, here's who our investments are for the past quarter. We've taken that actually as structured data, because we don't really care about them as businesses, we care about what their investments are. So we want the actual facts about like, okay, this business invested this amount of money at this number of shares in this other company. So all of that became structured data in the database. So we've got the pure text data from the public companies who are reporting what they do, and then the structured data from the investment companies. This was also important to me as we went through this. I told you, okay, the data prep was a nightmare. I also then want to be very careful about how I structured the data, and similar to like when you're doing any kind of data modeling, the way your model looks should be based on like the questions that you want to be able to answer, right? You change your data model to like optimize for that. So here, I took a very incremental approach to this. The strategy that I have actually for all of my data modeling that ends up being knowledge graphs is I start with the minimum viable graph. What is the smallest graph I can create that is useful? And then I add to that or extract from that more stuff as I need to answer more questions that aren't easy to answer given where I started. So it's extract some useful information, create data records out of that, then I enhance those data records either with some indexing typically, and then I expand, and the expanding part of it is, okay, for the records I have, how are they connected to other data records? This lets you end up with these patterns of data. The patterns of data end up being things like, okay, person knows other person, or company invested in company. That, as you can imagine, as I'm just saying it right now, when you've done the model right, you can actually read the model to somebody else and it makes sense. The way that it makes sense to us by just reading the data model also ends up being that the results you get from the data model make sense when you package it up and hand it to an LLM. Very specifically what I ended up doing, I took the raw text, okay, pre-processed, got it all down to JSON, imported all that text. You'll hear this term chunking talked about quite often in this kind of idea of doing RAG applications. Chunking is I've got a really big text that is way bigger than I want to search on. I want to have smaller chunks of that. People sometimes go down all the way to sentences. So like every data record is just a single sentence. Sometimes it's paragraphs. Sometimes it's chapters. It depends on like what the actual data source is. This step seems simple. Take a bunch of text files, chunk it up, and save it. That is so impactful, deciding how you're chunking, because you want to end up with a set of chunks of text that map really well to user questions. So that when you're taking a user question and you're doing this idea of text embedding, you're converting it into some numbers. Those numbers are what you use for actually matching other documents that might be similar to that. That process there isn't easy to get right. So you end up like even spending a lot of time at this step, as simple as it seems, experimenting with like, okay, what is the different chunking strategy that's going to map really well to user questions that are user information search type questions, right? So you play with this a little bit, you end up with these chunks of records. That's fantastic. The next step after you've got those chunks, like as you're iterating around this, is you add what's called text embeddings. And the idea of an embedding is that the LLMs operate on vectors of information. And a vector is just an array of floats, basically, right? And it's an array of floats in what is called a vector space. And a vector space is just really a multi-dimensional thing that is the same as we already know from Cartesian mathematics, right? We already know 2D space really well. We know if there's a point here and there's a point there, we know there's a distance between those points. That same idea is all that matters for all this vector search stuff. Except instead of like having just an X and a Y, you've got 1,000 different dimensions. The math is still basically the same. It is still, okay, given this thing and given this thing, they've got some position in space, in this vector space. You can measure the distance between them. You can measure the angular difference between them. And that's what's called like doing the similarity, is actually doing this calculation about how far apart these 2 points in space are. So this is the part here where you take the text you've got and you basically pass it to an LLM and say, hey, LLM, given this text, what would you use as a vector for this? It gives you a vector. You save that into the database. You go on with your life. The next step then is, since we've got all of these chunks of text, we know that the text was already sequential. Okay, let's not lose that information. One of the nice things about having this in a knowledge graph is you can actually take each bit of text and just create a linked list. Okay, here's the first text, here's the next, however many you've got. And now, once you've landed somewhere, you know how to go forward and backwards from the text that you've landed on. That helps both for expanding the context, so that once you have a similarity search, you might land somewhere. And okay, my favorite example here is like, let's say like you have some text about diffusing bombs. I love the MacGyver example here. Okay, how to defuse a bomb. You land on like this bit of text that's the most important bit of text and explains exactly what you want to do. But the very next bit of text says, but first, right? But first, like don't cut that wire until you've done this other thing, really matters. So you want to expand a little bit to make sure you've got enough context for like the before and the after when you're answering questions. The linked list lets you basically end up doing that. You end up repeating this pattern. This is the full length now, for doing just the first step. I extracted some data from the raw text, made it into some data records, did the vector embedding, and did the linking into the linked list. This is my minimum viable graph. It's not a very elaborate knowledge graph right now. It has just one kind of thing. It's just related to itself. That's not too exciting yet. But this is already very powerful. You can already do the vector similarity search with this. You've got an expanded context, this kind of window of context you can supply. And when you're building a user interface, you want to be able to do not only, okay, great, here's some text that answers your question. You want to tell the user, oh, by the way, here's the original text that it came from. The LLM has generated some kind of a summary, let's say, or it's made up a poem about it. But you can supply the user the original text itself and let the user go to the next page, go to the first page, let them actually have a user experience that is a combination of both chat plus some data navigation that we're already used to doing. We can continue this process, and I'll go on here for a little bit about this. So we've got the original text that was broken up into chunks. We know that they came from one document. We'll just attach that document. We say, okay, all these chunks came from this document. Let's go ahead and create those documents. And from that document, you should be able to navigate to the head of the linked list. This lets you, again, do nice user interface kind of navigation of the data space in addition to actually adding extra context to the data set. Because that form, the document that everything came from, you can now actually have some summary text on that level. Now you've got hierarchies of information, hierarchies of knowledge inside of the representation. Then we take that other set of data that I talked about, the investment companies, and we know that there's management companies, we're calling them, they own stock in these public companies. So let's just go ahead and import that. Those are going to be two sets of records. Those records are related by an own stock in relationship. In knowledge graphs, we talk about those kinds of terms. It's the same idea of extracted some data from the CSVs, created data from them, connected the data. And here, rather than using a vector search, what I care about is a full text index for the names of the companies, because people never type in exactly what the name is of a company that's filed public filing, right? You're not going to necessarily oh yeah, it was Apple Incorporated LLC of whatever. Like whatever the long name is doesn't matter. Just find me Apple. So do a full text search for that. All these companies, all these management companies also have addresses. So the next step ends up being, okay, great. Addresses are pretty interesting. If you want to find out companies that might be near their investors, that's a good pattern to know about. So if you're looking for an investment round, you want to find investors near you, perhaps. You can find out investors near you who've invested in similar companies to you. That'd be useful to be able to ask, right? I don't know how many of you are in startups today, but if you're looking for funding, that's a good pattern. Now that we've got the structured data and we've got the unstructured data, obviously we connect those together. This is what the full knowledge graph ends up looking like for this particular data set. On the triangle side, it's the structured data that we imported. On the right-hand side, that's the unstructured data that is then connected all the way through. This is the full table of all the steps that I took. If you want to try to reproduce this yourself, this is the one to take a snap of. I also have a Python notebook that I'll share the GitHub link for that basically goes through all the data import, all the details of how that ended up working, and then you can try it out. And if I've got enough time, I'm going to try to do some live demo on that. This process can continue as much as you want to. And again, driven by the questions you want to be able to ask, you end up continuing to elaborate on the data set, either adding more data sources, connecting those data sources in, or extracting information. So there's this idea of what's called named entity recognition, which is from the text that you already have. When these companies describe what their business is, they often in the text they mention other companies that they talk about. They might mention people, they might mention industries. All those things are concepts that you actually pull out into like now a structure around the knowledge. So not only is it, here's the information I know from this company, but we know the other company that they talked about, so we can say they cited some other company or they know some other company or they do business with. So create that relationship explicitly. We also might know that they're in a particular industry, so you can connect them to something of an industry node, like they're in technology. And then to the technology, you can find all the people that are in that technology. So you continue to elaborate on that based on the kinds of questions you want to be able to ask. And the last bullet here, of course, is the most important. I think none of this really matters unless you make this relevant to users. You want to be able to keep track of the user's history. Here's what this user has asked about before. This is the idea of, ChatGPT has memory now. The memory that ChatGPT has isn't kept in the LLM. That is kept, of course, outside of the LLM, because why have an LLM trained on just like a script of text you've entered? That's a database problem, right? So keep the memory of all the interactions from the user, allow the user to plus or thumbs up, thumbs down, responses you've gotten back. Use all that as a feedback loop for improving the overall data set, improving it over time. The more people use the data, the smarter the data becomes about the individuals. Okay. Here's where I get to rely on the Wi-Fi and cross my fingers that this is all going to work. I mentioned to one of my colleagues this morning, I woke up, came here, the first thing I tried was, okay, let me see that this is all going to actually work, and nothing did. So fingers crossed that actually it's going to work when I do this now live. So here's my Python notebook, and let's clear out all of what I've got here. In this notebook, and again, I'll share this link. I'm going to take a look at this. You guys can see this all right? It's okay? Okay, cool. So, okay, this is just a Python notebook that has access to a database that I've created. And actually, let me switch over to the database first. Okay, so this is a database called Neo4j. That's me, ABK of Neo4j. So this is a graph database. This is the graph model that is inside of the database that obviously shows exactly the same thing that I just showed you in the slides. This is the actual data side of this. And let's see. Okay, so we've got the managers that own stock in companies, that files in form, where the form has been chunked up into chunks. Okay, great. And just to show that this is actually data, you can run some sample queries like, if I just want to find companies, I can click on the company. This is the query that was run. You may not have seen this query language before. This is a query language called Cypher. It's a graph query language. It has elements of SQL, a little bit of functional programming thrown in for fun. And the fundamental thing that it does is data pattern matching on records. So we have this idea of pattern matching, and the pattern match that I'm doing here is the simplest possible pattern. Find me a pattern of single records, or we call them nodes. So that's the parentheses there. Find me nodes where company, they have the label we say. They're labeled as companies. Find some companies, return that, here I'm calling it N, and limit it to 25. They're showing up as just these lovely blue circles. We can change the circles to see that these are actually companies. We've got Atlas, whatever, News Corporation, Nike. And because we know that it's actually data, you can take a look at what the data records look like as well. So you get a little bit of visualization, which is nice, but then it's actually data, so you can do work with it, of course. Okay, so that's the database that we're working with. And I'm going to try to rush through this because I know I'm running low on time. And that's not a good sign. I'm sure the network is going to be awesome. Okay, what could possibly go wrong? Okay, so this Python notebook I have has got access to that database. I'm using a framework called LangChain for actually doing the integration for what's called a question answering session. So I've set up all that in the notebook, and again, you can take a look at this code later. What's going to end up happening when I run this compare all QA function, it's going to take that text, it's going to do an embedding of that text, and then run that against a couple different strategies for how to answer that question, and then show what all the answers might be like. So the strategies are going to be, let's do just the plain, what's called vector search. So do the similarity search with vectors. Let's do the vector search, but then add a result window, so a chunk to the left, a chunk to the right. Let's package all that, see if that changes the response. And then we're going to take the vector search plus a pattern match that goes from the chunk to the form, to the company, to the management company, and see if that helps for questions as well. The final strategy is, for me, still the most mind-blowing, is that, okay, let's just see what happens when we ask the LLM, can you generate a query for this question, and run that query, and see what response we get for there as well. Okay, fingers crossed. It is at least running, it hasn't errored yet. Okay, cool. So the pure vector search thinks it knows about News Corporation, Nike, and Dow Jones. Dow Jones is probably mentioned somewhere, but I know that it's not actually in the data set. And the vector search plus the, what is this one here? With the window, has a bunch of other companies. Okay, those are all great. They're mentioned in the text somewhere, but I know that I don't have them as publicly filing companies, so that's interesting. And then the vector search plus the pattern, this reaches all the way into the investment companies. You can see, if you know these names like Vanguard Group and BlackRock, okay, now we've gotten some investment companies in addition to the public companies like News Corp and, Foxtel, I suppose, here as well. And then in this last one, it tried to generate some cipher. Remember, it had that match clause I just showed you? So it managed to generate the match clause for companies and return company, com.company name. Okay, that's great. And then it knows specifically, so this is awesome. So the query doesn't always get generated correctly. It's not 100%, it's like, it's good, but it's not perfect. This was a well-generated query. It ran the query, and then it found out, and I know that these are in the data set, all those technology companies that are mentioned there, which is awesome. We can then ask questions like, all right, in a single sentence, NetApp is listed there. Tell me about NetApp's business. Okay, the first two are pretty much the same. Cloud-led data-centric software company. Yeah, okay, that's good. Adding the pattern match, which is adding in the investors. Doesn't make a difference to the question about NetApp, so that's actually pretty good. Okay, the query generated here is a little weird. We got a query that ended up going from the company to their location, what their address was. That doesn't seem relevant to me, but that's what the LLM decided might be a good query to run. But because it knows about the company, it was at least able to answer a question about the company, so that's not terrible. What if we ask about something a bit more subjective, like what's most important to the company? So this exercise that I'm going through here it's fun for demonstrations. It's also incredibly important when you're developing applications like this. You have to manually go through and look at the results. There's this whole step that you'll hear data science people talk about called eval or evaluation. That's data science speak for running tests. Let's exhaustively test the system. Here's a bunch of questions. Here's the answers we expect. Measure how good the answers are for the questions, right? You have to do that by hand on small batches of things before you extend your data set. So exactly the exercise I'm going through here. This is basically unit testing for an LLM. Okay, so that question got a couple different answers. Okay, the result window thought partnerships were more important than what the business does. The pattern match is kind of the same as the pure vector. And then look at this elaborate query we got for this question about what's most important. Now we got still where the company has an address, but also where the company filed a form, okay, that has some chunks. So now it's like, okay, let me reach out all the way to the chunks, package all that up. And it has a nice one-sentence summary. It's kind of up to you to decide, okay, which of these is the most relevant, right? So this is part of the art. It's not hard and fast, like this is clearly the best. There's some amount of like human intervention required here to decide which direction you want to go, how to route a question. And I'm running low on time here, so I'm going to get to some of the other fun stuff. So exactly as you can imagine. Okay, you can ask, who are the investors? Fine. We're going to expect the query that reaches out to the investors to be better here. Okay, the first two, of course, have no idea about the investors. It's not in the text. We know that's in the structured data. The third one is the one we expected to do really well, and it did. It knows that NetApp has these investors, Vanguard, BlackRock, and PrimeCap. And then the cipher generation. Come on, OpenAI, you can answer it. May get stuck. I might have just broken ChatGPT. So, oh, there it goes. Okay, it took a little while to actually get that. But okay. Yeah, okay, so it ended up with a reasonable query. It's not a bad query, but it's not useful for the actual information we want to. I'm running out of time here, so I'm going to do just one last query, which is, I think, a really interesting. You know, you can look through all these. Again, I'm going to make the GitHub repository available, so you can just play with this yourself. It is a ton of fun once you've got this set up to see what works, what doesn't work. And when you're building a RAG application, the whole challenge is first get it to work at all. And then once you've got it to work, you'll quickly realize that the real challenge is getting it to work well is really hard. The first step is easy. The second step is difficult because you've got to try to figure out for the different strategies you've got, how do you pick the right strategy to match the user's question that gets the right result? And so, all right, I know that I'm out of time, but I'll run, I don't know. Oh, this is the one that I think was fun. Okay, so what companies are at risk from climate change? Okay, so the pure vector search, and even with the window, kind of generic answers. Yeah, okay, this is it's actually not a terrible answer, fine. The vector search plus the pattern match ended up having actual companies mentioned that we know are in the data set, Nike and Western Digital, that's good. And then the output is truncated. Let's see if we can get to the rest of it. Ah, there we go. So again, a nice query was generated. Oh my gosh, no, not a nice query. No, bad LLM. Okay, so this is not, okay. So that last one is a complete failure. So this is why we do the testing. That query there, like if you have this in a production system, you don't trust what you're getting back at any point when you're interacting with the LLM. Here I'd ask the LLM to generate a database query for me. You don't want to just take whatever the hell it produces and run it. You want to make sure it's not going to delete data. You want to put in like access control things, all the usual database stuff we care about. Make sure that you don't get SQL injection via LLM would be a terrible, terrible thing, right? So you avoid that. While on your own laptop, knock yourself out, obviously. Okay, I know I'm over time, so I'll just say, I'll go to this. This GitHub repository is where you can find all this code. It is live updated because I keep working on this stuff. If you want to learn more about Neo4j as a database and how you use it for knowledge graphs, Graph Academy, our online free course for learning about Neo4j, is fantastic. There's a whole ecosystem of stuff around building this with Neo4j. Go check that out. And the last thing I'll say is, of course, thank you.